Okay, we have a study done on proctored and non-proctored tests, and we have the results. So they've already figured out the summary statistics for us, which we've got over here. From normally distributed populations, we're not assuming that the standard deviations are equal. And so we want to test the claim that students taking non-proctored tests get higher than them taking proctored. So we're calling mean 1 proctored. And so our null is always equals. So we know it's A, B, or C. D is wrong. And we want to say that the proctored is smaller than the non-proctored. So that's this one, mu1 is less than mu2. Okay. Then to do this in StatCrunch, we are going to open up StatCrunch, which is one of these 4 million screens I have open. Right, there we go. And we're going to go to stat, T-stats, okay, to sample, come down here, with summary, okay? And then we're going to put in the information. This is just the information they gave us. So our first one had a sample mean of 76.58, sample standard deviation of 10.39, sample size of 31. And so I'm just copying this, 81.83, 21.41, and 33. Now to find the first one, this is our hypothesis test. And remember now this is a little bit different than what we did. If this is true, so mu1, we subtract it from both sides. So we had mu1 is less than mu2. If I subtract mu2 from both sides, I get mu1 less than mu2 is less than 0. So I want is less than. So in other words, it's going to be negative if this is true. Okay, and then I'm going to hit compute. As a way, if you wanted like the summary stats, I click on that and it's going to give me the summary stats as well. So there's my T-stat. So negative 1.26. I think it had me round to that. Let's go back here. I have too many screens. Yep. Negative 1.26. Now I can actually look at my p-value right there, and that's greater than 0.05, so I would reject. You could also then at the same time look up the regular T-stat just like you would. So for instance, if I opened up my chart, T-table, and I'm doing this at 0.05, so my area in one table is 0.05 up here. My DF, my smaller one, was 30, so coming down this to 30 is 1.697, so it'd have to be less than negative 1.697. I'm not. So in either case, you can see the p-value or doing it that way, I'm going to fail to reject. I don't have sufficient evidence. Now I want the confidence interval, and I can also do this in StatCrunch. So I'm going to come up here at Edit, and you could also just go, if I wanted to, I could just repeat what I did here, stat, T-table, to sample with summary, and put this all back in. It's just that going the other way, I don't have to re-put in all mine. So results here, I can go right back to this is the one I just got. And I can go up here and I can go Edit. And now I'm going to click on confidence interval. Now here's the thing. I want 0.05. I did a one-sided test, okay? So that means all my stuff was in one tail. To replicate that same test confidence interval, I have to have 0.05 in each tail, so I need a 90% confidence interval. I've got to make it bigger because I did a one-tail test. That's the reason I'm doing that. And then coming here, so then my lower limit right here, okay, let me write this down. Negative 12.244 and 1.744. Okay, so negative 12.244 to 1.744. And then does this? Well, yes, it does, because it contains 0, which is saying the same thing as, okay, well, it could be no hypothesis difference. And so we got it correct. And so that's how you get it to do it in StatCrunch.